I'm gonna record this one as well. Hey Kim, we are starting our notebook. That's the link to the notebook. But I think I'm gonna type this one just so that it looks a little nicer than I did before. So I have 4x minus 3, and then that's the part it stops. Here, I'm gonna put it in parentheses, and I'm going to plug in this piece right here, the 3x minus 5. So here, I'm gonna put, and I'll change that to a different color. 3x minus 5. And I'll go back to that. Everything else comes down. So again, we're kind of like smushing one equation into the other equation to make one big equation. All right. But in order to be able to do that, you have to have it say y equals or x equals first. And again, guys, if I ever get to a point where you're like, wait, can you explain that again? Put it into chat. Just say like, hey, can you do that again? Or just write again, or raise your hand. Like just the symbol of raising your hand will let me know to repeat myself. Or if you guys have any questions, like how did you get that? Just put it into chat. Just let me know. All right, so now that we've smushed both of these two equations together, I can simplify. So I'm going to be able to distribute. So first I need to bring down my 4x because nothing's happening to the 4x. However, something is happening to this 3, and negative 3 needs to be distributed into both of these, both, not just one. So negative 3 times 3x, negative 3 times 3, negative 3 times 3. And again, I'll change my color, gives me a negative 9x. I'll distribute again. Negative 3 times a negative 5. A negative times a negative is going to give me what? Positive. Positive what? 3 times 5 gives me 15. Everything else comes down. So far, again, all of this stuff is fairly new. If you guys wanted to type things up, see how I've been doing these, going back and forth between drawing and typing. Do you have to draw? I would rather you guys at least like show these drawings. And again, you guys can add that to these pieces right here. Don't add it here because it'll, it won't move with those pieces, but we'll add those here in a little bit. From here, I need to combine like terms. So I'm going to look at the left side and I'm going to see 1, 2, 3. I have 3 numbers. I can't have 3 numbers. I should only have 2. So I'm going to see, do I have 2 that have x's or 2 that don't have x's? So I have an x here and I have an x here. So I need to combine those. So we're going to add or subtract them up. So I have that with red. 4x minus 9x. I have $4. I want to spend 9. How much more do I need? I need, because 9 is bigger, need what? 5x. 9 minus 4 gives me a 5x. Everything else comes down. All right, thumbs up if we understand that piece right there. Because that's a part that I know in last class, I did lose a couple of people there. All right. Awesome. From here, you guys are fairly used to this piece, and I'm going to switch over to drawing everything. So I have to get rid of this positive 15. So how do I do that? I'm going to subtract 15 from both sides. I'm going to subtract 15 from both sides. My negative 5x, nothing happened to that, guy. So I'm going to bring that down. My 15s go away. Equals same sign. So add and keep the sign. What this means is I owe you $35 and then I owe you another 15. I still owe you But how much do I owe you? Add it up. 5 plus 5 gives me a 10. So 0, carry the 1. 3, 4, 5, so 50. I need to get rid of this -5. So I'm going to divide everything by that -5. Do not forget that negative. My 5s go away and I'm left with x equals negative and negative give me a positive. 5 goes into 50 10 times. And again, that piece is right here. So what I'm going to do is not throw. I'm going to move this piece. I'm going to delete all of these. I'm going to move this piece up. And I'm just going to fill in those blanks. So I distributed. And then I combine like terms. Someone's like, hey, that's one solution, isn't it? Yeah. How do we know it's one solution? Because I already have x equals. So if I look here, when I have x equals, I know I'm going to have one solution. So going back and forth, as soon as you guys get x equals a number, you guys know, it's going to be one solution. So I'm looking for a point. So what point are they intersecting? So I know my x. However, that means I need to find where my y is at. So where is my y? How do I figure that out? Well, I'm going to take this 10 and I'm going to plug it back into the original equation. So I'm going to go wee, and I'm going to plug that into x. All right. So again, I'm going to type and then I'll move those pieces from the bottom up. So I get y equals 3, but then in parentheses, I'm going to type in that 10. Minus 5. Y equals 310 minus 5. So y equals 3 times 10, 30 minus 5, and then 30 minus 5, 25. So I can grab that piece. It's right here. How many solutions is that? One solution. Grab that piece here. So there is that first question. Okay, sounds good. That's fine. All right, give me a thumbs up if you guys are good with that one. Clap if you guys need some more time with that one. And start kind of thinking, guys, do I like this method? Do I like this more than graphing? Because you can pick either solving things by substitution or solving things by graphing, whichever one you guys are better at least when it comes to the final. I want you guys to practice doing both of them today and tomorrow, but one might be easier for you guys than the other. All right. For this middle one, looking at both of these questions, equation 1 and equation 2, both of them have y equals 10. So both of these have y equals. So does it matter which one we plug into the other? No. So I'm gonna take this guy right here. And I'm just gonna plug that into this y. All that does is sets them both equal to each other. So I'm gonna have 5x, oops, plus 2. Thank you, Alexis. Equals 5x minus 3. So Alexis, we are doing our notebook and I'm putting that into chat. Click on that and this is the first page. So you haven't missed too much. I am typing it, but all the work is down here at the bottom and I will eventually move it up. Oh, I was saying that this is like, we're just doing our notebook. So I'm typing all of this stuff, but you don't have to type it. All of it is down here at the bottom and I'll eventually move it up. Like I moved it here. So you don't have to type anything, or you can at least move the piece. So like, this is the piece that we're going to be dealing with. You can move it up and what I like change on it, you can change on that one. All right, from here, I look at my both sides. I have a 5x and a 2. I can't combine them. I have 5x and a -3. Can't combine that either. Hey, Manny. We are doing our notebook. I just put that into chat. This is still the first page, so I'll show you all of it, but all of your pieces are down here. Even though I'm typing certain things, I'll be moving all of these pieces up once I'm done with that section. So I can't add 5x and a 2 because they don't have x's. I can't add 5x and -3 because they both don't have x's. So I'm going to look at both sides and I'm going to look at the x's. And I noticed that 5x and 5x, I can get rid of both of them. Normally I pick whichever one is smaller and I move that to the other side, but they're both the same. So I'm just going to subtract this, which ends up getting rid of this one as well. So you're just getting rid of both by subtracting whatever or doing the opposite. So since it's a positive 5x, I'm subtracting 5x from both sides. So this goes away and that goes away. So what do I have left over? I have 2 equals -3. Is this true or is this false? So thumbs up if it's true, clap if it's false. Let me know, does 2 actually equal -3? Thumbs up if it's true, clap if it's false. Well, yeah, that makes no sense. 2 and -3 are not the same number. So that is not true. So looking here, back at last week's notebook, what is it going to be? Are they both not the same? No solution? Or are they both the same? Infinitely many solutions. Well, they're not the same, so it's no solution. So again, I'm going to erase this and move my pieces. I'm going to move this piece up. And edit the pieces that I needed. That goes away. That goes away. And again, this is no solution. Why is it no solution? Because 2 and 3, -3 are not the same. They do not equal each other. All right, give me a thumbs up if you're good with that one. And we have one more to go for this page anyways. Clap if you guys need more time. Okay. So let's look at that first, that last equation. looking at 1 and looking at 2. One of these is already pre-solved for us. Which one has y equals? Is it 1? Thumbs up. Clap if it's 2. Which one is already like solved for us? Y equals or x equals? Is it 1? Thumbs up. Clap if it's 2. Yeah, this one right here is already solved for us. Because it says y equals. Is it always going to say y equals? No. And we'll see that on the second page. We'll sometimes have it say x equals, and that's fine. Either one, we don't care as long as one of them is solved for us. Sometimes we might have to move things around to get it to look like this, but we're not going to make it too complicated for you guys. So y equals 3x plus 1. We're going to take that 3x plus 1 and we're going to plug it into that y. So if we type it, and again, you don't have to type it. All of that stuff is already on the bottom. I have y parentheses instead of that y though, I'm going to plug in 3x plus 1. And then everything else comes down. So again, all we're doing is we're taking this first equation and we're plugging it into the second one. And then we can solve it from here. And let's see, maybe our x's go away. Or maybe we get x equals in this. So let's distribute. I have 4 times 3x, 4 times 3x gives me 12x. 4 times 1, don't forget you have to multiply 4 to both of them. Give me a positive 4. Everything else comes down. Oops. Almost forgot that x. See, I make that mistake all the time too. All right, so looking at both of these, we got to get rid of one of the 12s or one of our x's. So we see 12x and 12x just like before. We're lucky enough to be able to just get rid of it. Sometimes we don't get to have that option. So what's the opposite of a positive 12? Negative 12. So subtract 12x from both sides. And I'm left with 4 equals 4. So looking again at our last week's notebook, what happens when I get a true statement? Because 4 equals 4, that is true. So that is a thumbs up. 4 does equal 4. So is it no solution? No, because it is true. So it has to be infinitely many solutions. So I am going to erase all of this stuff. And move those pieces over. Now, I added extra pieces and I don't want to add those extra pieces. So I want you guys to fix it for me. So we're going to draw our arrows. My 12x's go away. But from here, can you guys like just highlight this and then erase it or just draw over it? No one really ever does this piece. You can if you want to make it 0, but this is as far as you really need to go. You don't have to go anything further than that. So you don't have to make it 0. Whoops. We're going to move that piece and that piece. And like before, I don't want this So I'm gonna type in that T. I'm gonna fill it in white. And I'm gonna put 4 equals 4. That way it kind of looks like it was supposed to be like that. So let me zoom out for you guys. And it should look like that. So those are the 3 types of solutions you guys can have. You guys can have one solution, you can have no solutions, or infinitely many. One solution is going to be if you get x equals and then y equals. No solution is going to be if they're the 2 numbers you end up getting are not the same. Even if it said 2 equals -2, those are 2 different numbers because one's positive and one's negative. However, if you get it like the last one where it's 4 equals 4 or -5 equals -5, then that's going to be infinitely many solutions. So give me a thumbs up once you guys are ready with that. Clap if you guys need more time. Okay, Alex. So this is the part where I'm going to switch over. Pen. Oh my God, you're so mean to me. Thank you. All right, so we're going to be going back and forth. We are done with page 1. We're going to switch over to page 2. All of the stuff is down here. You don't only have to move in one piece at a time. And like we did before, I'm going to show you guys step by step, and then I'll add a little bit to each one of these, but not much. So again, looking at both of these equations, we have 1 and we have 2. One of these is already solved. What does that mean by solved? It means that it already has y equals or x equals in the front. So seeing here, our question 1 is going to be like this. So here's the deal. I know with question, like for the first page, we did all of our work going down. I actually don't like that. I don't like having the x's here and then y underneath. I like it kind of like this, where I put one question here and one question here. The reason why I like this is because I can make kind of a circle path that lets me know that I've completed everything. So if I can make a circle, then that lets me know like I've finished everything. Because I've had a lot of times where kids only do the X part and forget to replug it in. And when they're doing it like this, I kind of feel like you guys have more of a chance of doing that mistake versus doing them side by side. Like I said, it kind of creates a circle, which kind of helps you guys remember, I still have one more step. So what we're going to do is we're going to take this 4x. Yes. And then someone was already asking, when the x is by itself, that means 1, right? Yeah, what you guys can do is you guys can put invisible ones right here. Whenever you guys see an x or a y by themselves. So we're going to take this 4x, and this is important, super, super important. I need you guys to do this, and I need to be able to hear it from here. You need to take this 4x, and you're going to go, wee, and you're going to plug it into this y. The wee is very, very, very important. Like, I need to hear it. Like, and then con ganas, okay? Like, not just like wee. No. It's wee. Trust me, it'll help you in the long run. So take that 4x and goes wee. I'm going to plug that into this y. So the x, nothing happens to the x. Again, you guys can put in that 1 if you guys want, so that it lets you guys know there's 1 of them. And then instead of this 1y, we're going to plug in 4x. So again, this is our 4x. Nothing happened to the 10, so it comes down. Now I can see that both of these are x's, so I can combine them. What does combining mean? That means that we're going to add them or subtract them depending on our signs. So I have 1 plus 4. 1 plus 4 gives me a 5x. So 1 plus 4 gives me 5. Bring down my 10 because nothing happened to that. Now I need to get rid of this 5. So how do I get rid of 5 when they're side by side like that? We're going to divide them both. Divide them by what? The number in the front. So divide both by 5. My 5s go away. And I'm left with x equals 5 goes into 10 2 times. And this is what I mean by my circle. So we're going to take this 2. And we're not done because this is x equals 2, which is great. But I need x and y. So what do I need to do? I'm going to take this 2, and again, very important. We're going to take this 2 and go, and we're going back to that first equation. Some of you guys like, I'm bleeding from the ears, doc. Like, seriously, oh my God. So I'll change the tone so it's not high pitch, it's kind of like low pitch. And plug it into this equation. So y equals nothing happened to the 4 that comes down, but instead of that x, I'm going to plug in that 2. And then solve it. This one like is a super easy one. Y equals 4 times 2. 4 times 2 is 8. However, when we're solving for things, x comes first. Okay? Oops. First. I did that all backwards. First. So it doesn't matter if x was solved first or solved second. The x is always first. So our equation, our solution is 2, 8. If I don't see this, and all I see is x equals and y equals, that does not count. That's just like when you guys were graphing, and if you guys just drew your lines, that does not count. I need to see the point. And again, x goes first and then y. It's ABC order. So if I go to my notebook, go to page 2, find the one that says 2, 8. There it is right there. I'm going to drag it up and hope that the class kick ghost doesn't mess with it. Again, if you want to help yourself out and add those ones, you guys can. For some reason, this line is missing. I don't know why. And that should do it. So thumbs up if you guys are good with this one. Clap if you guys need more time. Again, if you guys have any questions whatsoever, if I'm going too fast, if I'm going too slow, any of those comments, please put it into chat to let me know so that I can modify it for you guys. Because remember, this is your time. So make sure that you guys are taking advantage of it. All right, I didn't see any claps, so we're going to move forward. So we're going to go to the next question. All right, looking at question 1 and question 2. One of these is already solved for us. It's question 1. Now, some of you guys are like, is it always question 1? No, it's not. I just made it always question 1 for your notes to make life easier since we're just starting. So it's not always going to be the first one, but I'm trying to help you guys out. So I have x equals 3y. So I'm going to put that one first and then the other one second. And again, the 3y is already solved for x. And if you guys wanted to, again, you guys can add that 1 right there. Technically, you could add 1 right there. So I'm going to take this 3y. And what are we doing? That's right. We're going to go, whee! And we're plugging it into x. We're not plugging it into y because it says x equals, not y equals. So we're gonna have 2, that stays the same, but instead of x, we're gonna plug in that 3y. The negative 1y is gonna come down. Again, you guys can add that 1 equals 10. You guys can multiply this, 2 times 3. 2 times 3 is gonna give me a 6y. Bring down that negative 1y equals 10. 6 minus 1. I can simplify that. 6 minus 1. And this is where the 1 helps if you guys actually put it down. 6 minus 1 gives me a 5y. Bring down that 10. How do I get rid of that 5? By dividing both sides by 5. And I get y equals 5 goes into 10 2 times. So again, this is half of our circle. So we're going to take that 2. And what are we doing with that? That's right. We're going to go woo, and we're going to plug it into that y. So I get x equals 3. And instead of y, we're going to plug in that 2. So notice again, I like this pattern better versus doing it side by side or like long ways. It just, for me, makes a better flow. So what's 3 times 2? 3 times 2 gives me 6. Remember, x goes first. So even though this was done second, it's going to go first because y, because x, y, z. It's the alphabetical order, x, y. So come down here, find that problem right there. So it's right here. Drag it over. See if you need to add anything. Well, I need to add the we's. Wee. For some reason, it didn't take here. They did it over there. Didn't add the we here. So we. It's one solution, yeah. Again, if you guys want to add those ones, you guys can. And remember, this is first. And yeah, someone was asking, this is one solution? Yeah, this is one solution. And I can type it in for this one too. Do you have to do that part for this one? No. But I would rather you guys get into the habit of remembering which one's one solutions and which ones are two, no solutions and all that stuff. All right, give me a thumbs up once you guys are ready with that one. Perhaps if you guys need some more time. We have one more question and then we're going to go into our homework. The last question. Sorry that this is glitch. Let's put both of our equations up. Which one's already pre-solved? Obviously this one. This one says x equals. I'm going to take this piece and I'm going to plug it into my x. So wee, into my x. This x needs to be replaced with all of this piece. So it is a longer piece. So I'm going to put in negative 3y minus 9. Everything else comes back down. So negative 5y equals 26. So again, this gets moved. And then we're just going to place this next to where the x was. So let's distribute. 2 times negative 3y gives me a negative 6y. 2 times a negative 9 gives me a negative 18. Everything else comes down. I see I have like terms. I have a negative 6y and I have a negative 5y. I owe you 6. I owe you 5. So 6 and 5 gives me an 11y. I owe you now $11. Everything else comes down. So the negative 18 comes down and the 26 comes down. So here we're going to get rid of this 18. So I'm going to do my upside down T. I'm going to add 18 to both sides. Why am I adding and not subtracting? Because we do the opposite to get rid of it. Nothing happened to my negative 11y, so that comes down. My 18s go away. Equals 26 plus 18. 26 plus 18 gives me a 44. Let's get rid of that negative 11. Divide both of these by negative 11. Don't forget that negative. And I get y equals negative 11 goes into 44, negative 4 times. Again, this is only half your circle. You need to finish the other half. So I'm going to grab this negative 4 and I'm going to go wee and plug it into my y. So I get negative 3. Instead of that y, I'm going to plug in that negative 4. Bring down that negative 9. Let me. Negative 3 and a negative 4. Negative times a negative gives me a positive. So it's going to be positive 12. Bring down that negative 9. Twelve minus 9 gives me a 3. Here is my x, so this goes first. So even though it was second, it's still going to go first in my solution. So this is an x, this is a y, and it was a 1 solution. So let's look at our stuff. Drag over that last piece. Again, we're going to grab this. Remember, we went wee and we plugged it into our x. We distributed. We combined like terms. And then, oops, we took that negative 4 and we went wee and we plugged it in. Remember, this goes first. This is your x and this is your y. There you go. That's your second page. Now, thinking about what we just did, give me a thumbs up if you like this way of solving systems. Give me a clap if you guys like graphing instead, what we did last week. So thumbs up if you guys like this way, clap if you guys like graphing. There is no right or wrong answer. I just want to know which one you guys like. So thumbs up if you like this one, clap if you like graphing instead. Okay, a little bit of both. I personally, I like this way. I like substitution. I don't like graphing, but some people like graphing. Totally fine. More power to you guys. And the nice thing about the final is that you get to pick to do it either this way, or you guys can solve it by graphing. You'll have graph paper one way or the, or you'll have space so that you guys can solve it. It'll be up to you. All right, give me a thumbs up if you guys are good with this page. Clap if you guys need any more time with your notebook. Technically, your notebook is done. So if you guys are done with all of both pages, you guys can just mark it as done. We are not doing any more notes. We are doing activities from now on, or homework assignments. So you guys can start turning that in. And what we're going to do is look at your homework for today. So your homework for today is this one right here. I'm going to put that in chat. I'm gonna type in my name. You guys should be logging in. And it looks like this. It's 2 pages. So there's 4 questions here and then 3 questions here. I am going to do one of the questions down here at the bottom. So you guys can pick either question 3 or question 4. Whoever gets the most votes in chat will win. You guys see that it says 1 solution, no solution, or infinitely many. What you guys are going to do, you'll either circle infinitely many or no solution. But if it's 1 solution, you're going to type in what the solution was. So if it was 2 and 3, then you would write 2 and 3. So if it's infinitely many, circle that one. No solution, circle that. 1 solution, circle that one, but you have to tell me what the point was. Now, I want you guys to practice graphing on this one. So yes, I would like you guys to graph this one. And then for question 2, you guys are going to do substitution on this one. Just so that I can see you guys practice. Next, tomorrow we'll do where you guys can choose either or, whichever way you guys want to solve it. However, you do need to show me work for questions 3 and 4 and for these. If I don't see work, I'm going to take away points. So make sure that you guys are showing me your work, not just picking one of these. You do need to show work. Where can you show work? There's plenty of space down here to show it, or you guys can do it on a separate sheet and then attach it. You technically could attach the picture here. You can go to the camera and then upload from computer or upload from camera. So it should pick me and it should take a picture of me. So there you go. So I can be like, yeah, capture that. Oh my God, I look horrible in that picture. Yeah, I mean, look at that. Oh, there's my backpack. That's my daughter right there. That's my son, my husband, and my daughter. But yeah, you guys can take a picture. You guys can make this smaller, obviously. Do not make it too small where I can't see your work. If you guys wanted to put it into your homework, or you guys can just attach it to Google Classroom and do it that way too. It's up to you. I am not picky. I just want to see your work. All right, so I'm going to give you guys a second. Put it in chat. Which one do you guys want me to solve? Do you want me to solve 3 or do you want me to solve 4? Put it into chat. Which one do you guys want me to solve? 3? Got 2 for 3. All right, we'll do 3. So let's do 3. So the way this is going to work, actually, let me zoom out. I'm actually going to type them up here. So negative 2x plus y equals negative 1. I'm going to write the other one. Negative 4x plus 2y equals negative 2. Now you might be like, wait a second. Why do we have to show work on this one when we're graphing and we're not using substitution? Because these 2 right now are not solved to look like this. Y equals mx plus b. It should look like that. If it doesn't look like that, then we can't graph it. So we have to make it look like this first. These are not solved for y yet. So I can do that here. Well, let's look at our y first. So here's my y. There is no number in front of it. So that's actually really, really nice. This is a 1. When it's a 1, perfect. It actually means that we have less work to do. So I'm going to do my upside down t to move this 2x over to the other side. What's the opposite of a negative 2x? Positive 2x. So we're going to add 2x to both sides. So all of this stuff that we are doing, guys, all of this solving was from last quarter. So even if you haven't been really paying attention lately, you should be able to do this and catch up, because this was from last quarter, not this quarter. I can't combine these two guys, so I'm going to leave it as 2x minus 1. Cool. So let's do my slope. My slope equals what? My slope is 2, so I'm going to put it over 2 over 1 so I can see my slope. So what does that mean? I'm going to go up 2 and 1 to the right. And then what's my y-intercept? My y-intercept is -1. All right, cool. So we can graph this. So I'm starting at -1 because it says right here, -1. And here is my equation right there. So it says -1. Okay, cool, -1. So I'm gonna plot my point there. From there, my slope says up 2 and then 1 to the right. So from here, up 2, 1 to the right. Again, if you guys want to draw your lines, I would probably suggest that to make life a little bit easier, or just zoom in a lot. It's totally okay to zoom in a lot. Up 2 over 1, or I can go backwards, down 2 over 1, down 2 over 1, down 2. And I'm going to connect my dots. And I'm going to make this red. Try and extend it as far as you guys can, because remember, this is about where are they intersecting. Make sure you are using the line tool, not drawing it, or else you're not going to get points. I'm going to send it back to you guys because you do need to use that drawing tool, or else you're going to get it like all messed up. All right, so we did the first one. We're done with that one. Now let's solve this one. Cool. So here is my y. Unfortunately, it does have that too. So that means I'm going to have to do a little bit more work. So that's fine. It starts off the same though. I have a -4. So what's the opposite of a -4? +4. So positive 4x. We're going to add 4x to both sides. My 4x's go away. I'm left with 2y equals, again, I can't add these guys because this -2 doesn't have an x. So I'm going to put 4x minus 2. Here is that extra step because we do have this +2 right here. We do need to get rid of it. How do we get rid of it? By dividing. So we're going to divide not only that one, but these two as well by 2. My 2's go away. Now y is by itself. Equals 2 goes into 4 2 times. Minus 2 divided by 2 gives me a 1. Can you guys tell me, by just looking at your two equations, how many solutions do I have? Can anyone let me know as I am filling out the rest of this information? So my slope is 2 over 1, so up 2 over 1. And then my y-intercept is -1. So what can you guys tell me about how many solutions I'm going to have? Look at your two equations. What can you tell me about them? They're both the same equation. This is 2x minus 1. This is 2x minus 1. So what happens when I draw one on top of the other? This is negative. So I'm going to go over and over and over and over. What ends up happening is that my line is on top of this line. So how many lines do I have? It looks like I only have one because they're on top of each other. So looking back at that graph, which one says that the two lines are the exact same, looks like only one line when you graph it. That would be this one. So I'm going to go to my homework and I'm going to circle or highlight many solutions. So again, when they both are equal to each other, so y equals 2x minus 1, y equals 2x minus 1, you know right away it's going to be many solutions. However, if this would have been like minus 4, then only the slopes are the same, but the y-intercepts are different. If that's the case, like this, it would have been no solution. So that's the difference between the two. Whoops. So if they're exactly the same, it's infinitely many solutions. If the number in the back is off by whatever number, then that's a no solution. One solution, you should get your slope could be different numbers. So this could have been like a 3, this could have been a 4, or this could have been a negative and this one could be positive 2. Positive and negative 2, that would be fine too. Now, again, I do need to see this work. You guys can either do it like I did it down here at the bottom, or you guys can do it on a separate sheet of paper. Here in the back, all you're doing is like you guys did with your notes. You're taking this piece right here and you're plugging it into X or into the Y. This one is on the bottom, but you're still plugging it into Y. And this one's also on the bottom and you're plugging it into Y. And then circle, one solution, no solution, or infinitely many. Yes, I still need to see all of your work. But other than that, that's it, guys. So I'll leave this one here so that you guys can take a picture. Don't forget to do your exit ticket. Work on all of your missing assignments. If you need anything, please let me know. But give it a go. Now you have 2 videos that you guys can look at, either this one again or the one from first period. But yeah.